Okay, so we have Nick has a bag of quarters and dimes. So the bag contains quarters and dimes. He's holding 200 coins that amount to $32. How many dimes does he have? Okay, so that's pretty, again, once again, we're looking at a blank sheet of paper. We have no idea what to do. So what I always suggest is let's start reading each phrase and start labeling things. So he has a bag and has quarters and dimes. So let's let Q equal the number of quarters. Okay, the number. And D will equal the number of dimes. Okay, so we have that. And continuing, he's holding 200 coins. So what does that mean? Well, it means if we take the number of quarters and add that to the number of dimes, we have 200 coins. Okay? Now, the next part is a little bit different. It says it amounts to $32. So this is when you sort of have to remember, this is the number of quarters. Now, if you had 1 quarter, how much would that be in dollar amounts? Well, it would be 0.25 times that 1 quarter. So that is how much each quarter is going to be. So if you had 1 quarter, if Q was 1, you'd have 25 cents. If Q was 4, it'd be 4 times 25 cents would be $1. Okay, and similarly for the dimes, each dime is going to be 10 cents, and then times each dime. So this is going to be the amount, this is going to be the total amount of the quarters, total amount of the dimes. Okay, make an arrow, it's not really an equal sign. Okay, and then continuing with our question, we have $32. So if you take 25 cents for every quarter plus 10 cents for every dime, and that's going to equal $32. Okay, so these are our, so we've got it all set up. Again, we went through each phrase and wrote everything as much as we could, and hopefully we have enough, which as it turns out we do. Why? Because we have 2 equations with 2 unknowns, and as you recall from your middle of algebra, you can solve using either combination method or substitution. We will use substitution. Let's rearrange this equation down here. Let's let D equal 200 minus Q, and we can now substitute D into the first equation, or the second equation. So we have 0.25 Q plus 0.10 times 200 minus Q equals 32. Okay? And I mean, technically I should have dollars here. Dollars and dollars. And then of course if you divided the whole thing by dollars, these would all cancel. So I actually skipped that step. As you can see, I've taken away all the money units. And all we're left with is Q. So let's solve this equation. Okay? This becomes 0.25 Q plus distribute that. 0.10 times 200 is 20. 20 minus 0.10 Q equals 32. Okay, and then let's combine like terms. So this becomes 0.15 Q equals 12, in which case Q would equal, so you have to do this in my head, I don't have a calculator on me, 0.15 Q, 10, okay, take a look at that, it's 80, had to run and get a calculator, apologize. So Q equals 80, and again it's under 200, which is a good sign we might be on the right track. And if Q is 80, the total number of coins is 200, so that means D must equal 120. Okay, so these are our solutions. Let's go back to our original question. How many dimes does he have? 120. Okay, but finally we want to check our answer. Okay, so if he has 120 dimes, 10 cents each, that's $12. Okay, and if he has 80 quarters, let's see, 10 quarters is 25 is 250, so 40, so that's $20 in quarters, which is $32. Okay. Okay, let's take a look at the second question in this video. The Math Club, great place, has its annual dinner, and they charge adults $5. Must be a heck of a meal. And the student tickets are $3. And according, it was a big showing. The club had it sold 215 tickets and raised $895. So what the question is asking is how many adults attended the show when they break down who showed up and who paid. So again, we're going to take it as we kind of have a sense of what's going on. We're working with cost as well as number of tickets. So chances are we're going to end up with two equations with two unknowns. So let's work through our problem here and start writing down some variables and equations. So it had its dinner, okay, the dinner, and the adult tickets were $5. So let's call A an adult ticket. Okay, this is an adult ticket. And each one is $5. So the revenue from each one will be 5 times A is the revenue, adult revenue. Okay. And then similarly, the student. It's a student. Okay. And 3S is student. Okay. And I actually should let's make dollars. We'll show all of our units here. Okay. And again, this is the number of tickets. A is the number of adult, number of student. And the club sold 215 tickets. So it sold adult tickets plus student tickets will equal 215. Okay. And they raised $895. So the amount of revenue from the adults was $5 times the number of adults plus $3 times the number of students, and that added up to $895. Okay, two equations, two unknowns, and I did label everything so we can have the correct units. Okay, and once again we'll use substitution. So take this equation up here. Let's solve for A. A is equal to 215 minus S. Okay, and we'll bring it down here. Okay, so $5 times 215 minus S plus $3 times S equals $895. Okay, so here's our equation. We're going to solve since we have just S. 5 times 215 is $1,075 minus $5 S, okay, plus $3 S equals $895. And I'm leaving the dollars in to intentionally show you how leaving the units in can be helpful. Okay, and collect like terms. So negative 5S plus 3S will be negative 2S dollars equals, we'll bring this, subtract 1075 from both sides, and we will end up with $180 negative. Okay, and we'll divide negative dollars from both sides, so 2S equals 180 and S equals 90. So the good news, 90 is less than 215, so apparently 90 students. Okay, and then of course that means how many adults? 125 adults. And again, we answer our question, how many adults attended? 125 adults attended the math club dinner. And then finally, let's just check our answer. So if 90 students showed up, $3 a piece, they paid $270. And 125 adults times $5 a piece, that's $625. And the total for both groups would be $895, and our solution is correct. And the third question is the tortoise and the hare. It's a distance and rate question. Okay, it's pretty straightforward, but once again, you have to concentrate on writing the correct equations and then solving for multiple variables. So let's take a look at this. We have the tortoise leaves at 9 a.m. Okay, so let's write 9 a.m. Tortoise leaves. Okay, he's going east at 2 miles per hour. And the hare, fortunately, is going east as well, so we'll ignore the direction because they're going the same direction. But the tortoise is going, his rate is 2 miles per hour. And let's recall distance equals rate times time. Okay, so the tortoise is going 9 a.m., 2 miles per hour. Okay, and the hare is leaving 9 hours later. So we're going to write, we're going to make this 6 p.m., but more importantly, the amount of travel time for the tortoise is going to be 9 hours. So T for the tortoise, so T tortoise, here's its rate, and the time is going to be T plus 9, because it's getting 9 extra hours of travel. And the hare down here is going to be 8 miles per hour is this rate, and he's traveling T time. So if the hare goes for 3 hours, the tortoise goes for 12 hours. 5 hours, 14 hours. So we have, again, we're looking at distance and rate times time. So we have the rate and we have the time. And the distance is distance. So here's the distance, the rate, and the distance, the time, and the rate. The distance, because they're going the same amount. When the hare catches the tortoise, he's going to be going the same amount. So distances are equal. Here's their times, and here's the rate. So let's set up the equation. So we have for the tortoise, we have distance equals rate times time. This is tortoise. So distance, we don't know what it is. The rate will be 2 miles per hour times the time, which is T plus 9. And the hare is distance equals rate times time. The distance is equal to the rate, which is 8 miles per hour times the time. And luckily, notice the distance is a common variable. So we can just set these up equal to each other because they're going to go the same distance. So let's put these together, substitution. So 2 miles per hour times T plus N equals 8 miles per hour times T. Okay, and we can cancel these units because they are the same for both sides. So let's cancel the miles per hour, and we're left with 2T plus 18 equals 8T. Therefore, 6T equals 18, and T equals 3. So these are hours. So the time is going to be 3 hours is when they are going to meet up. 3 hours for T. So that's 3 hours for the hare and 12 hours for the tortoise of travel time. So if the tortoise left at 9 in the morning, and he traveled for 12 hours, that'll be 9 p.m. And if the hare left at 6 p.m. and traveled for 3 hours, they'll meet at 9 p.m. So the first part of the question is, what time did they meet? They met at 9 p.m. because they each traveled. The first one traveled 12 hours, the other one traveled 3 hours. And then the second part of the question is, how far did they travel? Well, this is a great way to check our answer, actually. The tortoise traveled for 12 hours at 2 miles per hour. Therefore, it traveled 24 miles. And the hare traveled for just 3 hours, but he was going 8 miles per hour. So he ended up going 24 miles as well. So it just goes to show that our answer is correct because we were able to check it. They each traveled 24 miles and they ended up meeting at 9 p.m.